So this goal that we just watched was voted the greatest goal in the 20-year history of the Premier League in an issue of ESPN, the magazine. It was claimed that at the moment of impact with the ball, the foot of Wayne Rooney was rotating at a speed of 2,000 degrees per second. Okay. Is it humanly possible to move at 2,000 degrees per second?
Apparently.
Yeah. Yeah, so what does that figure mean? What does it mean to be moving at 2,000 degrees per second?
Take the center of mass, foot, and draw yourself a nice circle.
Right, like you see how many degrees of a circle the foot would move in 1 second. So 2,000 degrees is like 6 times around the circle. Yeah, in 1 second, right? So you can't actually maintain a speed of 2,000 degrees per second, right? Maybe in space, yeah, right. Not during a soccer game on Earth. So you actually can, in an instant, be moving that fast. You just can't maintain it, right? So how do you think they calculated that number? How did they come up with 2,000 degrees per second? Yeah. They looked at where his feet were over a very small time interval, or where his foot was over a very small time interval. Like they said, oh no. I have to redo my settings on here. Okay. So let's say his foot's, oh, hold on. Should have checked this yesterday. It is? I thought I hit pause. Oh, no, it was still recording. Oh, well. Okay. So they looked at where his foot was at an initial point in time, right? And then they looked at where his foot was some time later, maybe like 100th of a second later, right? And they looked at the change in degrees, right? Like what is that angle? What's the change in degrees divided by the change in time over a very, very small time interval? Because it obviously wasn't a whole second, because he would have been flipping around in the air, right? Yeah, but over a very small time interval, they were able to say he was moving that fast. Rates of change, and in particular, instantaneous rates of change, how fast something is moving at an instant, is at the heart of calculus. We're going to be seeing these rates of change throughout the course. Now we're going to have a little look at an Excel file about plant growth. And first we're going to watch the complete growth cycle twice, and then we're going to come back to the packet. Okay, so all the problems that we're going to tackle today involve calculus. Okay, so I'm going to give you some things to work on. Among other things, calculus allows us to find extremes on a graph, like maximum and minimum points. And it opens the door for us to understand with great precision the behavior of graphs. So we already looked at some highlights from the syllabus. Part of your homework tonight is to read the whole syllabus carefully and let me know if you have any questions on that. So we're going to start our first group activities. The group activities are never collected, but working and struggling through them with your table mates will increase your understanding immensely. An answer key typically follows the group activities, so you can check your work as you're going. But check with your neighbors before you check the answers at the end of the lesson. If your group gets stuck, raise a flag. I'll put some flags on each table. You're going to be working with your classmates all semester. Get to know their names today. Introduce yourself and write their names. That's the first part of the activities. And I will come around and help you with the activities as needed.